part D, determine whether a carbocation is more greatly stabilized by an adjacent chloro group or adjacent bromo group. So these are the keys: adjacent bromo versus adjacent chloro. The easiest we can identify is by setting the leaving group to be the same. So for example, I can have HCl Br as opposed to HBr Br. The reason is we'll have HBr and HCl in the carbocation structure. So let me show that by drawing the structures. I can have, so I think I need to clarify, this was part B, this answer to part B, and this was C. And for part D, I can draw the, no, I'm not going to draw the phenyl. So I will just write pH. That's connected to 3 different substituents. But I'm going to draw the hydrogen and then the chlorine here. Okay. And then bromine. We can also have chlorine, bromine and bromine. From part A, we learned that bromine is a better leaving group. So we are expecting the bromine to leave first than the chlorine in the left-hand side compound there. So when we form a carbocation, it's gonna be like plus sign here. So you have bromine leaving for both compound. Okay. And then we have to see our hydrolysis data to see which one is faster. So we're comparing the HClBr, this with this. So our data confirms that HClBr undergoes a faster rate of reaction, therefore it's more stabilizing factor. So the answer to this is adjacent chloro group. Okay, having this in the carbocation is better than having Br. So adjacent chloro group. Okay, 31.1 versus 6.85. Now for part E, for these hydrolysis reactions, determine which factor is more important in determining the rate of hydrolysis: the stability of the leaving group or the stability of the carbocation. Explain your choice. Easiest way is by realizing that the carbocation resonance structure was really same for both chlorine and bromine. I mean, when we go back to part B and part C, we pretty much answer the same, except the numbers in the hydrolysis may be different. But other than that, the resonance structure was identical. Whether you have 2 or 3, you know, it's very analogous. However, our leaving group here, the HCl, the hydrolysis data based on the effect of leaving group is greatly impacted, meaning when you have BR-BRH and then you have a BR-BR-BR, that's as much as 200 times faster. And when you have HCl-Cl versus HBr-Br, that's 3 times faster as well. So we have this huge change by having a different leaving group. Therefore, to answer E, it has to be the leaving group.